Hello everyone. We now have a high-level overview of what databases are and how to model data to fit into a database. In this video, we're going to dive into the process of actually setting up a database on Postgres and then building out some entities inside that database. We'll look at how to create, alter, and drop tables, as well as how to connect to our database, both from the command prompt and from within some server-side JavaScript code. The goal here is not to have a working application already, but this will cover some fundamentals we need so that we can set up our data to start using it in later videos. So with those objectives in mind, let us begin. So to actually build my database, I'm going to use the command line tool. These instructions assume that you've already installed Postgres. So if you haven't done that yet, you should navigate over to the Postgres website, locate the installer, and download the one correct for your operating system. If you click through, it's just a bunch of clicking next. But once that's complete, you should have a PSQL command. And this PSQL is your command line browser. It allows us to explore our databases right from a terminal. The first argument I'm going to put on PSQL is this -u, and that takes the username. By default, the one user that exists on a new Postgres install is the Postgres user. So if I have PSQL -u Postgres, that'll connect me to my database server. Once I'm in here, I want to create a new database for this project that I'm working on right today. Every single time you build a new application, you should create a separate database for that application. Sort of like how when you're writing code, every time you start a new program, all that code should be in its own folder so that you don't have the remnants of past projects lying around. Similarly here, if we have our own database, everything that we make in that database will be a table and we won't see all the old tables. Actually creating this database is a two-step process. Step one, I need to make the user who's going to own the database. I do that with the create command, and I'm going to say I'm going to create a user mobets with login permissions, with the password, in my case, mobets. I recommend you create more secure passwords, but this will be easy to type for me. When I do that, you can see it responded to me that it created a role. So there is now this user mobets who can log in, and he's got the password mobets. What I want to do now is create the database demo, whose owner is mobets. So this is saying, create me a brand new database called database demo, owned by that user that we just created. And notice both of these are following the pattern from our last video. Because we're creating stuff that isn't data, but is instead structure around data, we're starting with this verb create, then we're saying the thing we're making, a user or a database, then we're providing our particular details, like the user's name, their permissions, their password. Once we've done this, I can /q to quit Postgres, and then I can run PSQL again, but this time use my mobets username and also supply that new database we created, the database demo. If I do that, notice the prompt now tells me I am logged in to database demo, and once I am in here, I am connected to that database I just created as that user I just created. From this point, normally what we do next is build out our tables. So one of the neat things about Postgres is there's this /d command that tells you about everything that exists where you are. Here, if I do /dt or just /d alone, it'll tell me there are no relations yet, no tables exist. If I want to create a table, the way I'm going to do that is with a create table statement, just like all of our other DDL we've done so far, start with the word create, then the word table, and then the name of the table. So let's say I wanted to create a politicians app, my running example. I would say, okay, well, one of the tables in this is going to be a chamber table. So I'm going to name it chamber. And then inside parentheses, I'm going to put each column that is part of that table. And these columns have at minimum two parts: a name for the column, and then the type of information that that column is. So I might say a chamber is something that has a name, which is text, and it's something that has a number of seats, which is an integer. So I put those two components here, those two columns of my table, inside these parentheses. It's almost like declaring a function or declaring a class. When I do that, the table is now created. If I /d, it shows me, oh, well, here is the one table, chamber, who is owned by MOBETS. And notice the C is lowercase there. Unlike JavaScript and unlike most programming languages, SQL is not case sensitive. In fact, in some dialects, even strings I just found out recently are not case sensitive. For us, though, anytime you see capital letters like the create table here, if that looks jarring to you, you can lowercase it if you want. But I prefer uppercase. For me, it makes it more readable so I can see the keywords versus the name of things, because name identifiers are kind of jammed in there in SQL, and this makes it easier on the eyes for me. So if you see uppercase letters, that's the reason why. I can also look at the details of this table I created. I can say /d chamber, and that'll show me, okay, the chamber has a name column, which is text, a number of seats, which is an integer. Looks good to me, like we did create that table. What I want to do now, though, is talk about how we could do this same thing from inside of JavaScript. So right now we looked at setting this up on the command line. I could just as easily write myself a JavaScript program to do the same thing. I could make a create script JS that I want to run just one time that sets up this entire application. So if I were going to do that, I would need a library to help me. Just like how we use Express to write endpoints and talk with the internet, we'll need to use another module called PG in order to talk to our Postgres database. So I can import PG from PG. And as is always the case with these libraries, that means I'll need to install this PG to grab it. Once I've got that, I now have everything I need to connect to that database right here in JavaScript. So connections in PG are represented as an object, and to create that object, I call new pg.pool. And inside this call to this constructor, I put all of the details of the connection that I am trying to establish. So I would say the host of this connection, the computer that this Postgres server lives on, is 127.0.0.1. You could also put localhost here. This is just the IP address where Postgres is installed, which for us is the localhost. We'll also need the port number, which by default, Postgres listens on 5432. We'll also need the username, password, and database that we want to connect to. So I made that user MOBETS with the password MOBETS. Yours would be whatever you called your username. And my database was database demo. And remember, this was created with the create role in the PSQL. And this bit here, the database, each application should have its own database. We shouldn't be reusing the same one for every single app we make. But once we've done all of that setup, we now have this connection object. And connecting to databases is not a guarantee. It's a very long-running, slow process. So it returns a promise. Our most loved or most hated feature of JavaScript here, we've got this long-running process, so we have to wait for it to connect. If I want a client that I can actually use to run SQL statements, I need to tell this connection to connect. And this is going to be a promise, so we could .then it and put the client in there, but we can also just as easily put the word await, say, okay, stop, freeze the program. Once you've got your connection, then we can go ahead and add more statements after that. So now I've got my client here, and I can give this client any SQL statement I want. I could say I've got a create statement, maybe another table that I know I'm going to need is the politician table, and each one of my politicians has a bio guide as text, a first name as text, maybe a last name, a state, which is 2 characters exactly, a party that is 1 character exactly, and an age that is numeric. More typically, this is sort of the formatting that we see on create statements. It's common to break up SQL line by line so that each column or each attribute you're talking about is on its own line. All of its details right off here on the right. You'll see why that's popular in just a minute, but this follows the same rules as our previous statement here. I'm saying I'm creating a table, giving the name, and then naming and typing each column of that table line by line. So that is creating this statement. If I actually wanted to run it, it's not enough to just write it in my code. I need to actually pass it to my client. And I do that by taking my client object that we got here and saying, I want to run a query, a SQL query that is this create statement right here. If I do that, the response of that is also a promise, so I can await that and say, let the result of this running query be this, and then console log out that the result of creating the politician table is this result right here. And that's it. That's all there is to running SQL inside JavaScript. We need our PG package, connect to the database, and then run our create statements right here. But if we do that, and then I run my create script, we can see we actually got back an object. I would need to stringify that object to see the result. JSON stringify, whatever is in there. And if we do that, it's actually going to tell me I can't run this script more than once. The relation politician already exists. So normally these types of DDL operations, either we do them on the command line, like I showed you in the beginning, or we do them in their own script that we just run as a setup, maybe one time. It's going to be very atypical to keep running the same create table over and over and over again, because a relational database actually doesn't like you to keep deleting and recreating everything. If we want to design a script like this, often the first step of this is going to be deleting anything that was there before. If we want to create tables, we must make sure those tables don't already exist. There are a couple different ways you can handle this. You could choose to make this conditional, like go out and check before you run it, or you can just say, delete whatever was there before. This is sort of a regenerate the database from scratch script here. If I want to do that, I can use one of our other DDL keywords. I want to say, if this table exists, delete it. That's deleting for DDL, so it's going to use the drop keyword. I can say client query drop my table politicians if it exists. And I can do that for politician. I can also do that for the chamber that we're going to remake in just a second. And here I am, once again, picking an action, choosing a target, putting some conditions here, and then providing whatever details. That is generally the format of every SQL statement. But now if I go and I run this again, it's going to tell me that I did not actually await the client. These lines have to be below awaiting the client. And then when we run it, it shows me here's the result of creating that politician table. We get back this giant list of details when the operation succeeds, telling us which verb it was doing, how many rows were affected, what those rows are, and all of this field information for the thing that was created. So in this case, often what I end up looking at is something like the row count. It's a nice, easy counter to show you that something worked. If we get that far at all in the script, though, we've now successfully created a table. And that is the basics of creating and dropping tables in SQL. It can be a little bit difficult to tell whether this is exactly the table that you want. One strategy for this is actually logging in on the command line and browsing through. If I go back to my database demo database here, if I /DT, I can see here's this politician table that was created. I can get the details of it right here. That is one way to check that everything was done correctly. Another way is to try to ask for data. So we don't actually have the keyword for that. It's not the focus of this video, but it is the select word. If you recall, I can say select everything from politician. You can see it's actually giving it to me in a table format here. Bio guide, first name, last name. There are no rows, so there's nothing actually in the table. But that's another way that you can check. That will actually be the focus of our next videos. Another common way that people do verify this is by going in a visual browser. So when you install Postgres, you get one such tool, pgadmin, that gives you the ability to visually go in, set up and create databases and even tables. There's actually some that come with every IDE as well. So you can see here, I have one installed in mine. And in here, it shows me my database demo as something I can connect to. I can also refresh this and see what tables are available in there. If I do connect, that gives me another way, if you prefer something visual, to go and look at your databases. This one actually needs to connect. So let me close and then reopen that connection. Actually, I think it is not logging in as MOBETS. There we go. MOBETS, connect. Now we can see here's this politicians table. I can see here's all those fields on it. Bio guide as text, first name as text, last name as text. One of the nice things about that is you can also add data right inside here. I could say, oh, well, W000123 I'll say this is Sally Smith, a Massachusetts Democrat who's 56. We can create rows and even save them right inside a visual tool like that. So that is something that's worth exploring if that is the way you're more comfortable interacting with data. But those are a couple different ways to verify that you have succeeded in creating or dropping tables on the command line with selects or by actually navigating in a visual browser. The last thing that I want to do in this video is talk about some other options that we have on the create statement. So here you saw the general format of this thing is create a table with a name, and then each column on its own row. There are actually several other attributes that we can put on our rows in addition to the type. So the big types are text and numeric. There are a couple others like serial, which is an integer that just counts up automatically. It gives it a default value. Bool for booleans that have true or false, and a couple different flavors of numbers. But the more interesting things that we can add are constraints on each of these columns. So create columns can be given constraints such as not null. If I add not null as words after a column, like I say, bioguide is text and it is not null, what I am communicating there is every single row of this table must have a value in that column. So it's actually common to have not null on pretty much every single column in your table, assuming that it is something that always has a value. It wouldn't make sense for us to really have a politician who doesn't have a name or a state or a party. So I might add not null to guarantee, and the database will actually enforce this extra check, prevent you from accidentally creating a half-finished person and adding them to your table. It will reject it if it doesn't have all the information. Likewise, I can postpend add a suffix that is unique. And if I say a column is unique, only one row can have any particular value of that column. No two rows will share one. So I might say bioguide is like an ID number. It's actually supposed to be unique. No two politicians should share the same one. And once again, this will allow the database to enforce that assumption I have. If I try to add another person with the same ID, the database will say nope, and it will just throw an exception right then. It won't allow the program to continue. I can also provide things like a default value. If I put default and then I put some value after it, does exactly what you would expect. It sets rows where you haven't provided a value to the value specified there. So this is sort of the nice other half to not null. If you put not null, it expects you must put something. If you also have a default value, then even if you don't actually put a thing when you insert, it'll backfill and give you that default. The last two are kind of special and related, and these are primary key and references. So these two are more about our relations. If you remember in the previous video, we talked about how entities get related to one another. In SQL, we denote those relationships, the attributes that are linking things together, with primary key and references. So the way that this works is primary key implies that a value is a unique value we can use to reference this entity in other tables. So I might say BioGuide is my primary key. And like I said, if it is primary key, you don't also need unique. Primary key implies it's unique because what we're saying here is BioGuide is how I'm going to find a politician somewhere else. Once I've set that up, I can then create another table. And in that other table, I can say, well, this references politician parentheses BioGuide. And that will say whatever I put in there must be an example that exists already in the other table. One example of this might be if we actually finish creating our chamber now with this new information that we know. I could say our chamber table is a table I'm creating, so create table. It's called chamber, and this might have in it a name, which is a unique primary key, which is not null. Each chamber might have a number of seats, which is an integer. It might have a term length, which is an integer. And it might have, let's say, a leader who is a politician. So if I want to be able to say the leader of the chamber is a politician from this table, I would say, okay, then the leader is just text. I'm not going to try to incorporate this entire thing. I'm just going to grab the BioGuide. So this leader is text that references politician BioGuide. And that's going to say, well, the thing here is actually one of the things from over there. And it will link them together. And once again, Postgres will actually enforce this. If I try to create a chamber, but the leader doesn't exist, it's going to stop me from even making that chamber. Fortunately, because it isn't not null, I can get away with not setting it. It can be set to nothing, but if there is a value, then that value must exist. So now I've got my chamber statement and I've got my politician statement. If I add a client query to also run this one, now we've got two different tables set up that allow us to represent our two different relations and the link between them. And actually, real quick, integer does need to come before the not null. The type comes first. So if we make that change, clear all of our code, and then run our program, both of those commands did not error out, so they should have succeeded. And now if I go and look at my database, there will actually be two different tables here. Our chamber that has this name with a number of seats. We could say there's a Senate with 100 people and 6-year terms. There's a House with 435 seats and 2-year terms. And I can check mark. And we've got the politicians who, like we said, we might have a politician from a state in a party with an age. And both of these can store data. But like we said, the one neat thing is in our chamber, if I try to set this leader to someone that doesn't exist, when I go to save, it says, nope, you can't do that. This actually violates an assumption that you told me. So now I come here and I try to set up that one that does exist. It will allow that one to come through. We can have rows that do exist as fields here, but we can't just put any old thing. And that's the idea of a primary key, is it allows us to reference this entire row by just this one field. We said BioGuide is a primary key in our politician table. So if I want to link this chamber to that one politician, I only need to put just this one reference to that primary key. I only need to copy just that value. One thing that is very common here is making IDs of your table that are just numbers that count up. So for the first row, you have a number 1. Your second row, you have a number 2. That's a really convenient way to have just a single number that you can put anywhere. But the trade-off for that is there is no meaning. So when you're looking here and you just look at just a number, it's much harder to identify which row you're talking about without exploring the data a little bit more. The last thing that I do want to show you is that you can also change a table after it is created. If I connect to my database, I can use the alter statement to say, I want to take some table, like the politician table, and I want to maybe add a column to that. So once again, the action I'm doing, modifying a thing. The thing that I'm modifying, a table, and then the details. On politician, I'm adding a column, member of, and this column is going to be text that references chamber name. Now I can say, well, here is this one extra thing on that table that already exists. And when I run that statement, now my politicians table has actually changed. Now there's this member of, and because it's a foreign key, I can't put just anything in here. I can put Senate or I can put House. But if I try to put some random other thing, it will actually stop me. But there is an example of updating a table. You don't always have to drop and recreate every time. If you just want to add a column or drop a column, you can write an alter table statement to make that change. I will tell you, if you do want to change the type of a column, it is often easier to add the new column, select the data over into the new column, and then drop the old column, just because changing a data type sometimes has unexpected effects. But in order to do that, you'll need some information from our next videos to talk about selecting and inserting data. So in this video, we looked at creating roles in databases, and then inside those, creating tables to represent our different relations. We also saw how you can drop a table that's already there to get rid of it, or alter a table to add a new column, or add some sophisticated constraints that will ensure data that gets added actually follows the assumptions you have. This is really the first example of how databases are an improvement over something like a plain file. Having the ability to go out and tell your data storage layer how these different things relate to each other makes it so you can feel much more confident when you're writing code that uses anything from your database. So in the next video, we'll look at how you can start populating and using some of that data. But I will catch you all in the next one.